In this video we're going to look at the types of steel structures. So typical single story steel building has a portal frame with a main frame there, and then it'll have smaller steel members called purlins which hold on the roofing, and girts, it's not shown here, but they are shown on the they hold on the walls, the side rails, and there's also longitudinal bracing, so to brace it all up to stop it from moving. So the different types of that main frame is portal frames. So in this case here, it's basically a portal. So it's the most common way of building single-story steel structures to provide a really long span there. So there's a big open space there, which enables, which is great for warehouses or things that need a big open space, which columns would get in the way of. So you can see that it's got the side beams there, the column, and then it's got the rafters connected to it. So it forms a sort of an arch, if you like, an arch shape, but they can be flat as well. It may be erected either as one structure, sort of built on the ground then lifted up, or you can sort of put the columns in and then lift the rafters into place and bolt them at height. The different types, as you can see, you've got the single slope, double slope, single span, double span, so you can put a column in the middle, or multi-span. So there's different types of portal frames, but they've all got the same sort of thing, that they are like a frame. So there's a picture of a portal frame there. You can see that they have the main portals connected up there, and they're just putting on the purlins, and then on top of that will go the roof. You can see there's a centre beam there that they're sort of holding in place, which is actually I'm not too sure, maybe they're putting it somewhere, but there's the columns and there's the rafters there. Lattice truss frames, so they're like a portal frame, but instead of having one member sort of doing the span, the rafters, you have a lattice truss, and obviously a truss allows a stronger span, a stronger member, and therefore it's a longer span. So they're usually triangulated, so that they're triangulated, you see this on bridges quite a bit, so it might be that you're trying to do a longer span, or you are trying to take a bigger load. So these are often used on bridges as well, because bridges have a much higher load and longer spans than a normal building. These are usually relatively light angles or channels, sort of bolted or welded together. It has less weight than if you just had a single girder beam of the same strength, and allows you to do much longer lengths, so you can get up to 50 meters with this type of thing. The truss is often constructed on the ground then lifted into place. There are a lot of joins that need to be made there, and trying to do it up in the air is just going to be too hard, too expensive. Better to build it on the ground and lift it into place. And here's a picture of a lattice frame there, so you can see that this one's actually so it's got those small members there to sort of form it there. So it's still got quite a long span, and it's got quite a big depth as well. And you can see that they've got the purlins ready for the roof to be put on. And here's an example of another bridge, which is the Auckland Harbour Bridge. So you can see they've got trusses there, and the bridge arch is also a truss system as well, because the Auckland Harbour Bridge has such long spans and really high loads. So you can see that that span there is like about 3-4 meters high, probably a bit bigger than that, probably 4 or 5 meters high. So they are quite popular for bridges. Auckland and Sydney Harbour bridges are just two examples. Another type of steel structure is column and beam. So you build the columns, you build the beams. Used for multi-story buildings, may be braced, so the beams and the columns just support the vertical loads with diagonal bracing. So these little red spots show pin joints, so they're bolted. They're not supposed to resist moment. The moments, if there's a lateral force being applied to the building, then that is taken by a truss system. So you'll have heavy steel trusses providing that system there, but these are just pin joints. The other way of doing it is to have a system to replace these braces with rigid joints, in other words fixed, welded, designed, moment resisting joints. So those are the two different ways of doing it. And you can see on the ground there they've got the moment resisting joints for each of the connections to the ground. So here's the beam and column system here. You can see the columns there and the beams sort of all, in this case here, I think they just bolted on. Yeah, so there's the bolt, the plate there. So they just build the columns first and then lift the beams up to bolt them on to like a Meccano set. The beam and column system may also be used in houses. So in houses you'll see that they may be made predominantly out of wood, but if the architect wanted a big span or an open span, then oftentimes they'll use a steel beam and column structure to provide that open span within the context of the wooden house.